examples of CLT connections during this presentation. Many years ago, some people were asking what is CLT. It was not too common material for buildings, but I think nowadays almost everyone knows about CLT. It's a structural timber member which is composed at least 3 bonded layers. Usually it's 3 or 5 or 7 layers, and at least one layer is perpendicular to the adjacent layer. So it's kind of composite element, and we can use CLT as an orthotropic plate. It means that we can the timber can act as a plate type member, and this will give a huge advantage in timber area. The other thing what we can use as a benefit from CLT is so-called locking effect, and we can use that in the connection part. So locking effect is means that when we have usual glulam or solid timber, then we have to check if this timber will split or not. And in cross-laminated timber, it's also possible, but it's not so common for CLT connections. So the splitting is avoided by the crossed layers. One thing we have to...
No problem. I can just go inside.
Maybe we can switch off TR's microphone. What we have to check if we design the CLT, we have to consider that it has wide face and edge face, and this is very important concerning the connection part. And the common use, or the let's say conventional applications of CLT are plate-like structures. This is like a replacement of reinforced concrete. We can make walls and floors with CLT, and here maybe the most beneficial part is that we can use CLT throughout many floors, like here in this our laboratory in Taltech building laboratory. We have this CLT wall here which goes through 3 stories, and it's possible to lift with a normal crane. So it's not possible when it is made of concrete. But there is also criticism, or CLT is often criticized because of this excessive material use, because we usually don't use the strength and stiffness fully from CLT. And I decided to show some examples or cases where this CLT can have real benefit. So it's not the usual common structure, but the places where we can use CLT's high strength and stiffness. So I have prepared some examples. For example, here we have one stage structure which is made with glulam frames, so the people can make here performances or sing or dance. And the stage needs electricity, of course. And in this example, the wall behind is made of CLT. if we try to make this like a not solid timber but glulam, this is hardly possible because this electricity needs very special cutouts from the timber part and channels for the cables, etc., etc. And this is very good place to use cross-laminated timber. Maybe here is not the case of the strength and stiffness too much, but timber as a pure timber plate is very right in this place. I have here some drawings of sections from different heights. The next thing, efficient use of CLT. Let's say I found an example calculation from BSB handbook. It's from Austria. TU Gras has made a really nice book about CLT or Brechbergholz when we talk in German. And there is an example building where it is shown the calculation of the shear in the wall, which is hardly possible to make with usual timber frame structure, because it has to take quite a lot of load, and in such places CLT is a very proper material to use. And also the floor elements, we can use floor elements, let's say 3 pieces for entire building. So it's also very beneficial in this case. The next slide contains also a formula. This is an example where CLT is used as a shear wall. And this is one of developments of company from Finland. It's called Unit Modules Finland. And they developed such a structure where the modules have steel columns, and between the steel columns is a CLT for pure shear. And this CLT is connected through the corners of the CLT, and here they used self-drilling dowels, and this wall is tested in Taltech. And actually this project, when this project started, it developed a much more wider project. We also investigated timber, cross-laminated timber connections, and also embedment strength for dowels in cross-laminated timber. And the result of this project, or it's my PhD actually, the result is this characteristic embedment strength for dowels, bolts, and rods for CLT whiteface. You can find now in Eurokodo. But here in this type of structure, this CLT is using very high potential. So what we can benefit from CLT, and we can use this dowel type fasteners here in this place. I also mentioned that this Unit Module Finland, they also developed some kind of robotics to create this type of shear wall together with columns. So it's very high sophisticated structure and high sophisticated production. The next example where we used CLT as a shear wall, it's also tested here in TalTech University, and this is so-called 369 pattern building developed together with Estonian Academy of Arts. And here on this picture is a second prototype of this module. And also there are already some ready made buildings with this system. And we tested the first prototype of this module here in Tallinn. And the idea of this structure is that every module has two frames which can take horizontal load, but in longitudinal direction there is no stiffness or no stiff element. And one option to achieve the stiffness in longitudinal direction is to put the other module next to the module we want to make stiff, so we can use the frame itself, or we can use the CLT shear wall, which is connected from bottom also with the double type fasteners. And also it is tested here in Tallinn in old laboratory. Yes, what I mainly presented now is more about dowel type connections, but when we use screws in CLT connections, it's actually, when I go back very slightly to this picture, this picture also shows that for CLT, so conventional buildings, usually we use angle brackets and nails, and the screws are maybe used in the places where we connect the plates each other. And in many cases, this connection doesn't have to take too much load. So this is more for a connecting reason. But when we need to design CLT or screw in the CLT, you already know this formula from the new Eurocode, where we want to calculate characteristic withdrawal resistance. We have to check the pull out from each timber member. So we can have a situation where we have on one side one situation, and on the other side the other situation regarding the withdrawal strength. Then we have to check the timber part for withdrawal and also the steel part, but withdrawal capacity needs this withdrawal strength, and the withdrawal strength formula has these two parameters, Kw and Kmat. We have talked about this Kmat. Kmat is considering the number of layers, so how many layers we penetrate with. This is not the case here, but how many layers we penetrate with treated part, and we can increase the withdrawal strength up to 15%. So when we have 7 layers, so it's the maximum what we can use. But maybe one beneficial part can be in the structures like this, so where we connect stiffening metal diagonal to the CLT. So here we can use this benefit where the screw will penetrate many layers. And also we have to be aware about the Kw, which considers the angle between the outer layer grain direction and the screw. So all calculations in CLT or all connection calculations in CLT are related, which are related to the grain direction, are considered as outer layer direction. So that's the main rule. So that was my part today. It went, yeah, a little bit faster, I accepted. So I can give more word to Enno, or if someone has a question, you can easily ask.
Yeah, I like to give the word for audience. We have actually Eero today on the long run academy session at the last time, I would say. We have some new academy coming in, which means that Eero will get a little bit so-called relaxed position and can participate as a member. But if some of you are having a question to Eero, then feel it free. You can put that in a chat field or you can ask directly. So if some of you have anything, then it's very welcome.
Yeah, I just want to ask Eero about the new Eurocode for the timber. Is it some new regulation for the distance for the connector for CLT or for the distance between the screw, as you showed before, like when you have shear between two walls, that you can have it calculated and have which distance depend on your screw. But is it some regulation in the New York code which say it, what's the max distance we can have it between the connectors or the screw? There's some limiting there.
Yes, CLT is all new in the Eurocode, because in previous Eurocode there was no word about CLT. I cannot answer precisely the distances, and but yes, these are regulated, and I'm a little bit careful about commenting on the current version of new Eurocode, because I have seen some parts of the new amendment. It means that there are a lot of things already changing or improving. But yes, these distances and edge distances are regulated. But yeah, I rather not to tell something very specific.
And about CLT and using outside house, what is your experience about it? Because
if I look out my office window, I can see the building which is standing outside for this reason. This is CLT in environmental class or use the class 3.
Service class 3.
Yeah, service class 3. Yeah, I always mix that with the steel steel class. And yes, this is not too much investigated part, and it's not allowed to use in service class 3 yet.
Outside, yeah. It must, you mean it must be like either we use it outside, but it must be protected from the direct rain.
Protected we can use.
Rain or snow.
Protected we can use.
Yeah.
I also had this in my presentation, this stage structure. So there is a covered CLT.
Yeah. And what about, do you have, maybe it's outside of our our presentation, but what's about the fire reaction or fire resistant in CLT, and when we use the screw, because sometimes they say you must have resistant like R60 and must for the both the we say element, CLT element, and for the connection. When you have the screw inside the, as you showed before, when you have inside the element, how we can translate it? What's your opinion about that? Can we say, okay, because the wall is almost 60, the screw will be automatic 60 because it's injected? What's your opinion about that? Because I get many questions from the site engineer.
Yeah, CLT fire, the behavior in the fire, yeah, it's investigated a lot here in Tallinn as well. And it's so CLT itself, but the connection part is yes, we need to cover the metal part, but there are more and more researchers where they investigated how the temperature will rise inside of the connection. And in Tallinn, we made an investigation where we heated the CLT, where was the bonded in rod inside the timber or inside the CLT, and I think the screw can have benefit here, because let's say if the temperature will rise a little bit in the screw, it doesn't affect too much the withdrawal strength. But the glued in rod was the glue was also heated up and lost the load carrying capacity. So here I think the screw connection can have much more place. Yeah, but yeah, it's better when it's hidden.
Yeah. Thank you.
Yeah, from my side, few words in the end. Thanks. If there is no questions, I'm looking at chat field. It looks like empty as well at the moment. So feel free to come shown in contacts, direct to me, DR or Radoslav. Also Eero is supporting us. What I wanted to say, our future academies in March, April, May and June, we focus on support tools, kind of like SWOOD. Here on the view side, you will see that SWOOD QR mark, and as we know, you're able to work on it on mobile phone, scan it in, go it directly on website. Next academy is on March 11th. We introduced SV Inspect Toolbox. Everybody's welcome to get the overview. Then we will open up also in May thermal insulation, software support on Excel. So we show you where to download it and how to work with that. That will simplify your work on thermal insulation, roof and facade connection areas. Then we coming some other reinforcement applications and notch applications, but you will hear more in then coming academies about those news. But here we are quite in a closed end, and maybe to get your attention before you leave, also with feedback from the poll that how did you evaluate today's academy, and you are welcome back in next time. So thank you very much, you everybody who were participating. And thank you very much also Eero, who run along the 12 academies with us. So I wish you all the best, and you are welcome to give us your feedback. Thank you.
Thank you.
here I will end the session of recording.
Thank you.
Thank you. Bye.
Thank you very much.